Hello, what we're going to talk about in this video is the difference between using variant data types and static data typing. So first of all, let's talk about what exactly is a variant variable. So we're going to demonstrate this with a couple of variables. As the creator of these variables, we would logically expect the character name to contain the name of a character in the form of a string, and the hit points to contain the number of hit points that the character has, classically as a whole number or integer. Notice that when we declare these variables, no specific variable types are explicitly mentioned. This means that the allowed values in each variable are automatically of type variant. Hence, because the allowed values are variant, we would say that these variables are of type variant. In Godot, a variable of type variant can be assigned with pretty much any value of any type. Another way to look at this is to think of such variables as being untyped, because they have not been restricted to a particular data type. Let me demonstrate this. At first glance, this seems counterintuitive, but what we must realise is that the name of a variable should not be confused with the type of a variable. That is, we should use the name of a variable to indicate its purpose, but the type of a variable controls how it can be used in code, GD script in this case. Because these are variant variables, we can even do potentially dangerous things like this. Self is a keyword in Godot and it refers to the current node. In this case, self is referring to main because this is where the script is attached. This does not mean that untyped variables are not useful, especially if you're not sure exactly what type of data will be in the variable. However, processing an untyped variable is slower than using a typed variable, as the type of data stored in the variable has to be assessed every time that the variable is used. It is also worth noting that once the type of a variable is set, it cannot be changed. This is not the same as changing the type of data stored in a variant variable. The variable itself is still of type variant. For example, this sequence of statements is valid even if it's not especially useful. To demonstrate that this sequence of commands is valid, but as we said not particularly useful, let's print character name after each command. And rather than type the command in every time, let's copy paste it. To copy paste the whole line in GD script, all you need to do is position your cursor in the line, Control C, place the cursor on the line where you want it to go above, and then press Control V. Let's print the hit points value as well, and we'll put an empty line after hit points. Let's run our little project and see what happens in the output area. Stop it because it doesn't really do anything. So in our output area, we've got first the print for hit points here, then we're printing 99, yeah, and we've changed character name to Eric the Viking, then we've done some string concatenation on the variable, then we turned it into a float, added something to the float, that's where we are here. Then we've assigned a reference to my button to the variable. That's what this is. And then lastly, we've turned it back into a string again by assigning the text property from my button. If we click my button, you'll see that the text property over here says button label, and that's what we've printed out down here in the output section. So we've managed to assign the same variable to 4 different data types. An integer, a string, still a string, a float, still a float, a button class, and then back to a string again. So let's clear this out and we'll start again and show the basics of static data typing. Let's show various different ways of declaring variables. This first statement declares a variable x1 and does not assign any value to it. This again is the variant variable type in Godot that we have already seen. It can contain more or less anything that can be assigned to a variable, hence this is not statically typed. The second statement declares another variable and assigns an integer value. This is still the variant type. Even though it starts off with an integer, this variable can contain more or less anything that can be assigned to a variable. The third statement declares a variable without assigning a value. However, this uses the colon operator to indicate that this variable can only contain integers. That is, the variable is now statically typed and hence is only allowed to contain the specified type of data, in this case, an integer. The fourth statement declares a variable and assigns a value and also uses the colon operator to statically type the variable as an integer. The value assigned at this stage must also be an integer. Let's add another line and demonstrate how assigning something other than an integer will give us a result other than the one that we might expect. If we look at our warnings down here and scroll down to here, you'll see we have a narrowing conversion. This is because the float is converted to an integer when it's assigned to x6 and loses precision. Our fifth statement declares another variable and this time uses the colon equals operator to statically type the variable to the data type inferred from the assigned value. In this case, an integer type is inferred and applied because the value assigned is a whole number. If the value was something else, for example true or false, the variable would be statically typed as, for example, a boolean, and so on. When you're writing code in GDScript, this is the quickest way to both statically type a variable and assign it an initial value. Let's show some more examples of variable declarations that use static typing in a valid way. In this case, we have forced x6 to be a float because this value here has a decimal point and a fraction after the decimal point. In this example, we're forcing x7 to be a string type because this value on the right is a string. In this last example, we're forcing x8 to only be allowed to contain references to control nodes, and we're initially assigning it to self, which, as we noted before, is the current node. If we hover over main, you'll see it says it's of a type control. When we type a variable in this way as a class, the variable can take a reference to any object that inherits from the specified class. However, the reverse is not true, as in it is not possible to assign ancestor classes. For example, if this statement specified a button class instead, the variable is not allowed to take a reference to a control node. This is because the control node is an ancestor of the button class, or in other words, the button class inherits from the control class via the base button class. To demonstrate this principle, this is a valid statement. Let's try assigning a non-matching data type to one of our statically typed variables. We'll use x7 and we'll try and assign a number to it. As you can see, it's highlighted in red and our error down here says cannot assign a type of int as string. Basically what that means is because the engine knows that this x7 is a string and can only contain strings, when you try and assign an integer to it here, it doesn't allow it, and hence the error. If we ran the project now, it would stop at this point and give us an error in the debugger. Let's take a moment to talk about the power of static data typing. We've already seen some of the benefits of static typing in passing, but let's be more specific and itemize the main benefits. Static typing locks a variable to a particular data type. By corollary, static typing prevents us from assigning a non-matching data type to a statically typed variable. Because of this, errors with data type mismatches are easier to catch, and hence debug. In Godot, many such errors are caught by the editor, most notably within the same script. Runtime bugs due to data type mismatches are also easier to catch and fix. The Godot engine works much more efficiently with statically typed variables than with variant variables. this performance boost to operations with variables can be anywhere from 20% upwards. So when is it best to use static data typing? The short answer is anywhere you can. The long answer is anywhere you can. In my experience so far, I have not found any downsides to using statically typed variables. There can be some gotchas when reloading data from a game save file, as the stored data may lose its static typing. However, these gotchas are easily resolved. Also, loading such data should be avoided if possible in a performance critical part of a game or application. If you'd like to know more about this, and particularly how to handle such situations, please leave a comment. Hence, as I said before, my personal preference is to use static data typing wherever possible, as this makes things run faster and is much easier to debug. Only use variants where it is very inconvenient or unavoidable. Let's clear this out and we'll do some more advanced examples of static data typing. Consider this statement where we are declaring an array. At first glance, this might seem like a statically typed array of integers. It is indeed true that int array1 can only be assigned an array. For example, a statement like this will generate 2 editor errors. If I click over here, we can see the errors. One error is from the array side of the statement, as it cannot accept a string value, and the other error is from the string side of the statement, as it cannot be assigned to a variable of type array. Let's try adding a new value to the array and see what happens when we print it out. Let's run our project and see what comes up in the output area. As you can see down here, we have managed to add a float value to the array. This is because int array1 is statically typed as an array. However, we have not statically typed the member values of int array1. If we also want to statically type the array members, we have to use a statement like this. This tells Godot that the array can only contain integers. Let's try appending our float to this array and see what happens. Notice that we haven't got any errors in the editor. However, let's try running the project and see what happens. As you can see, we now have messages in the debugger down here. If we click that, click at the errors, notice that it says we attempted to push back a variable of type float into an array of type int. In case you're wondering why it says pushback here, that's because the append function is an alias of pushback. Pushback basically means push a value onto the end of an array. In an upcoming tutorial, I'll be covering array operations of this nature. Let's also print the array and see what we have after this error occurs. As we can see down here, because the second array will not accept float values, the attempt to add the value to the array has failed. Let's go over some more examples of variables with static data typing. Yes, we can use static typing with constants. In this example, we have implicitly set the max angle constant to be a type of float. For our next example, we need to bring back our integer array, and we also need to declare a function. Here's our function. Just ignore that for the moment, we'll come back to it. Here's our variable declaration. In this case, notice that we have used the colon equals operator. This means that the counting function must return a value of a known data type. Otherwise, this statement will fail because it will not be possible to determine what type of variable, how many variables should be set to. A variable can be statically typed to pretty much any class in Godot. This is very useful when working with references to nodes in a scene. There are some exceptions, but they are outside the scope of this tutorial. Array members can be statically typed to both basic data types and classes. As a side note, dictionary and an array are both classes, they are not basic data types. Again, there are exceptions, but they are also outside the scope of this tutorial. Arrays of dictionaries are very useful. As we've already noted, a dictionary is a class, not a basic data type. One of the clues to this is that the editor shows the class name in green instead of red. There are some downsides to dictionaries which we'll cover soon. So what else can use static data typing? We've already alluded to this by creating our counting function down here. I'm going to change this a little bit to make it fully statically typed. The first line of a function is what's known as the signature of the function. There are two ways that this counting function is statically typed. Firstly, the arguments accepted by the function are statically typed. In this example, the function accepts exactly one array of integers. Attempting to call the function with no arguments, more than one argument, or with an argument that is not an array of integers will result in an error, a bug. Secondly, the variable type of the return value is statically typed. This part of the signature indicates what is the return type of this function. In this example, the function must return an integer value. As we saw before, we use this to set the type of the how many variable. Hence, the return value from this function must either be a literal integer, that is something like 0, 24, 99, etc., or must be a variable that is statically typed as an int. In this case, we're returning z, which is statically typed as an integer, but we could just as easily return an actual integer value. The editor tracks what such a function returns and will show errors in the script window status bar until the function returns the correct type of variable wherever there is a returned keyword. For example, if I now remove the return statement and wait a few seconds, you'll see it says down here, not all code paths return a value. If I just type return, it will now complain that we're not returning an integer. Put Z back in there and it will clear the error. It is worth using statically typed functions wherever possible, as they also improve the performance of your game or application developed in Godot. If a function does not have a return value, use void. We have done this in the demo function here. This prevents the engine from having to determine the function's return type and hence also provides a minor contribution to performance. There are two situations where static data typing is impractical or sometimes even not possible. The first situation is when we're working with dictionaries. As far as I can tell, it is not possible to use static data typing in dictionaries. Although a variable can be statically typed as a dictionary, the keys and values in a dictionary are inherently of type variant. I have tried a small experiment to see if using statically typed variables to set key value pairs would work, but the results were inconclusive. Given that I use arrays of dictionaries quite a lot, I would like to see static typing of dictionary members explicitly implemented in Godot, but I will leave that to wiser heads to determine the benefits and practicality of doing that. The second area where static data typing is not possible or completely impractical is when we have indeterminate variable types returned by functions. What I mean by that is we don't know what type of data will be returned by a function. We can demonstrate this with our counting function. If I remove the return type from the end of the function, the return type is now indeterminate. As a result, we get an error because what we're trying to do here is infer the data type of the how many variable from the return type from the counting function. However, the counting function doesn't have a return type, so this is invalid. In this case, there is a simple workaround. We can just use this syntax instead to force the how many variable to be an integer. However, if the counting function returns something other than an integer, the value will be discarded and the how many variable would have an indeterminate value. This is a relatively simple scenario and we have managed to apply a workaround. Unfortunately, this is not always the case. There may be situations where you are completely unable to determine the return type of the value from a function, and the only thing you can do is allow the variable assigned to the return value to be of type variant. And this is one of the key advantages of the variant type when it's used with variables. They can get you out of a hole like this with a small cost in performance. I have encountered this in my own project where an error occurs due to an indeterminate return type from a function. In general, when this happens in a complex statement, I would recommend going with the flow and just using a variant type variable. Thank you for watching. If you have enjoyed this video, please like and subscribe. If you would like me to expand upon any of the topics touched upon in this video that are not part of the core subject matter, please leave a comment.